Mojibake, from the Japanese character plus transform, is the garbled text that is the result of text being decoded using an unintended character encoding. The result is a systematic replacement of symbols with completely unrelated ones, often from a different writing system. This display may include the generic replacement character in places where the binary representation is considered invalid. A replacement can also involve multiple consecutive symbols, as viewed in one encoding, when the same binary code constitutes one symbol in the other encoding. This is either because of differing constant-length encoding, or the use of variable-length encodings. Failed rendering of glyphs due to either missing fonts or missing glyphs in a font is a different issue that is not to be confused with Mojibake. Symptoms of this failed rendering include blocks with the code point displayed in hexadecimal or using the generic replacement character. Importantly, these replacements are valid and are the result of correct error handling by the software. Causes. To correctly reproduce the original text that was encoded, the correspondence between two things must be preserved: the encoded data, and the notion of its encoding. As Mojibake is the instance of incompliance between these, it can be achieved by manipulating the data itself, or just relabeling it. Mojibake is often seen with text data that have been tagged with a wrong encoding, or not tagged at all, but moved between computers with different default encodings. A major source of trouble are communication protocols that rely on settings on each computer rather than sending or storing metadata together with the data. The differing default settings between computers are in part due to differing deployments of Unicode among operating system families, and partly the legacy encoding specializations for different writing systems of human languages. Whereas Linux distributions mostly switch to UTF-8 for all uses of text, Microsoft Windows still uses code pages for text files that differ between languages. For some languages, an example being Japanese, several encodings have historically been employed, causing users to see Mojibake relatively often. As a Japanese example, the word Mojibake, when encoded in UTF-8, is incorrectly displayed as AOA in software that assumes text to be in the Windows 1252 or ISO 8859-1 encodings, usually labeled Western. Under specification, if the encoding is not specified, it is up to the software to decide it by other means. Depending on type of software, the typical solution is either configuration or cassette detection heuristics. Both are prone to mispredict in not-so-uncommon scenarios. Therefore, the assumed encoding is systematically wrong for files that come from a computer with a different setting. For example, when transferring files between Windows and Linux. One solution is to use a byte order mark, but for source code and other machine-readable text, many parsers don't tolerate this. Another is storing the encoding as metadata in the file system. File systems that support extended file attributes can store this as user.cassette. This also requires support in software that wants to take advantage of it, but does not disturb other software. While a few encodings are easy to detect, in particular UTF-8, there are many that are hard to distinguish. A web browser may not be able to distinguish a page coded in UKJP and another in ShiftJIS if the coding scheme is not assigned explicitly using HTTP headers sent along with the documents, or using the HTML documents meta tags that are used to substitute for missing HTTP headers if the server cannot be configured to send the proper HTTP headers. See character encodings in HTML. Misspecification. Mojibake also occurs when the encoding is wrongly specified. This often happens between encodings that are similar. For example, the Eudora email client for Windows was known to send emails labeled as ISO 8859-1 that were in reality Windows 1252. The Mac OS version of Eudora did not exhibit this behavior. Windows 1252 contains extra printable characters in the C1 range. that were not displayed properly in software complying with the ISO standard. This especially affected software running under other operating systems. Human ignorance of the encodings still in use. Many are partially compatible with each other, with ASCII as the predominant common subset. This sets the stage for human ignorance. Compatibility can be a deceptive property, as the common subset of characters are unaffected by a mix-up of two encodings. People think they're using ASCII, and tend to label whatever superset of ASCII they actually use as ASCII. Maybe for simplification, but even in academic literature, the word ASCII can be found used as an example of something not compatible with Unicode, where evidently ASCII is Windows 1252 and Unicode is UTF-8. Note that UTF-8 is backwards compatible with ASCII. Overspecification when there are layers of protocols, each trying to specify the encoding based on different information. The least certain information may be misleading to the recipient. For example, consider a web server serving a static HTML file over HTTP. The character set may be communicated to the client in any number of 3 ways. In the HTTP header, this information can be based on server configuration or controlled by the application running on the server. In the file, as an HTML meta tag, this is the encoding that the author meant to save the particular file in. In the file, as a byte order mark, this is the encoding that the author's editor actually saved it in. Unless an accidental encoding conversion has happened, this will be correct. Resolutions. Applications using UTF-8 as a default encoding may achieve a greater degree of interoperability because of its widespread use and backward compatibility with US ASCII. UTF-8 also has the ability to be directly recognized by a simple algorithm, so that well-written software should be able to avoid mixing UTF-8 up with other encodings. The difficulty of resolving an instance of Mojibake varies depending on the application within which it occurs and the causes of it. 2 of the most common applications in which Mojibake may occur are web browsers and word processors. Modern browsers and word processors often support a wide array of character encodings. Browsers often allow a user to change their rendering engine's encoding setting on the fly, while word processors allow the user to select the appropriate encoding when opening a file. It may take some trial and error for users to find the correct encoding. The problem gets more complicated when it occurs in an application that normally does not support a wide range of character encoding, such as in a non-Unicode computer game. In this case, the user must change the operating system's encoding settings to match that of the game. However, changing the system-wide encoding settings can also cause Mojibake in pre-existing applications. In Windows XP or later, a user also has the option to use Microsoft Deplocal, an application that allows the changing of per-application locale settings. Even so, changing the operating system encoding settings is not possible on earlier operating systems such as Windows 98. To resolve this issue on earlier operating systems, a user would have to use third-party font rendering applications.